Today our topic is integration by substitution. This method is based on actually the chain rule just we use for the differentiation. The method of integration by substitution is based on the chain rule for the differentiation. If capital F and small g are differentiable functions, then we know that chain rule tells us that derivative of f of g at x is equal to derivative of f at gx and g dash x. That's f of gx is an antiderivative of f dash gx, g dash x. In indefinite integral, we can write it in this form. The integral of this term is equal to f of g of x plus constant of integration. As in differentiation, it's very easy to introduce an intermediate variable u. We see that this formula will become as that f dash u du by dx and dx. This will be f of u plus c. Here we rename gx as u and we obtain this form. Now if we write small f of u for f dash of u, so that the integral of f of u with respect to u will be equal to f of u plus c, and we obtain this simplified formula that integral of fu du by dx and dx, which is equal to f of u du. This formula is easy to remember, and we will apply this formula when we will solve any problem of integration by substitution method. Let us solve an example. We will integrate with respect to x by substitution method, and later on we will verify it by differentiation. The important thing is to select the factor u, whose derivative must be a part of that function. In this question, we have two factors, 2x and x square plus 1 under the root. We can write in this form. We write x square plus 1 under the root first and later on 2x. Right. We assume u as x square plus 1. Well, we can easily find the derivative of u here in this problem as a factor. Yes, x square plus 1 is equal to u. It will become square root of u, and this whole term is du, because we see that 2x is the derivative of u. If we differentiate and we find du by dx, it will be equal to 2x. So this 2x is equal to du by dx. Later on we can write it in this form, and it is very easy to solve by applying the power rule, and the power rule allows us to write it as, but our question is in the form of x. We will go back in x by backward substitution. We will write u as x square plus 1 and obtain this final result. We will verify by differentiating that if we take the derivative of this term, will we succeed to get this result? Let's see. We differentiate our answer with respect to x. 2 by 3 is constant. It will go outside of the differentiation, and we will apply the power rule here, which results in this form, while this factor is here, whose derivative will be multiplied. After simplification, we find the result, which is the same as given as integral. Sometimes we observe that we cannot find the derivative of the intermediate variable, which we assume as u. So we have to find the derivative of the intermediate variable. Let's see in this example, derivative is hidden here. We have to find the integral of this term. Let's see what we select as u. We know that if we select u as cos of x, then its derivative is minus sine x. While in the question there is no minus sine x but sine of x. We write minus sine x. Multiply this factor with negative sign, and also we have to multiply this factor with negative sign. And if u is equal to cos of x, then this factor is minus u square, while this part is du by dx, and this dx is here. Simplifying, we obtain this form of integral, and power rule will help us to obtain final answer in terms of u, which is later on backward substituted in x, and we obtain minus 1 by 3 cos x cube plus c. We can also check it by differentiating. Definitely we will find the integrand as a result. Let's see another example. The important thing is to select the u. Can we select the denominator as u? Or we have to select this part as u. We have to select the variable u whose derivative is hidden here in this problem. We have e raised power x in the numerator. If we take 1 plus e raised power 2x as u, then we have not its derivative in as a factor. And if we select e raised power 2x, it's also not possible to find its derivative here as a factor. We will select e raised power x as u, and our problem will reduce as 1 over 1 plus u square du. Let's see its explanation. We let u is equal, if we let u is equal to 1 over e raised power x, its derivative is this, which is not equal to e raised power x. So we will not select u as 1 plus e raised power 2x. But we know that e raised power 2x can be written as ex whole square. And we take u as e raised power x, then definitely its derivative is also e raised power x. Our problem will take form as in x, which will be later on converted in the form of u as 1 over 1 plus u square du. We can easily write it as tan inverse of u plus c. In back in x, we have the final answer as tan inverse of e raised power x plus c. We can check it by differentiation. Let's summarize this whole process. To integrate a function which involves an intermediate variable u and its derivative, the integrand in the form f of u and du by dx which is equal to this. Finally, we evaluate integral of f of u and then substitute for u its expression back in terms of x. Again, we see here expression in u, derivative of u. The given problem will be factorized as, and this question will be shifted in u as. And finally, the answer will be replaced again by backward substitution in x.